This video will explain the main idea of Adapa's ETL, what roles each module has, and briefly explain how different modules correlate with each other. Starting from a scratch installation of CouchDB, you are ready to go. When Adapa Stocks is launched, the application instantly starts the first supervisor, responsible for supervising the initializer, which tries to request data through all necessary design documents and databases. If any database or design document is missing, the initializer creates what's missing. It also fills up all symbol databases with tickers needed later on. With everything set up, the initializer loads the second supervisor. That supervisor is responsible for supervising the actual stock data fetchers, NASDAQ, LSE, and DAX server. These servers will instantly look up the local time and fetch when each individual stock market is open. The second supervisor is also responsible for loading a bunch of other vital modules. One of these are the symbol server. Its responsibility is to download lists from external sources containing fresh ticker information. If any ticker is missing from your database, the symbol server will insert that ticker. This will be repeated once every 24th hour, and its true purpose is to update existing lists if, for example, a company is taken away or introduced to the market. Other modules loaded are the batcher and the logger. These will be explained later on. How does a server work then? Let's use NASDAQ as an example. As mentioned before, this server first looks up the local time from your computer. It then compensates for New York time and compares that to the predefined opening hours. If the market is closed, the server waits for it to be open. However, when the time is within opening hours, it sends a HTTP request to CouchDB to retrieve the current list of ticker symbols relevant for NASDAQ. Each symbol is extracted and one process per symbol is created. These processes all communicate with MarketOnDemand.com by sending requests and receiving JSON in return. To handle errors, each process accepts any JSON structure or other HTTP replies, such as error messages. If, for example, the JSON data is insufficient, a message will be sent to the logger and the process will terminate correctly. This is usually the case when ticker data is not available for the current symbol. But let's say that Market on Demand realizes that we are sending thousands of requests almost at the same time and closes some down remotely. In such a case, the particular process will halt for up to 2 minutes and will then attempt to make another request until it either gets a correct reply or fails 3 times. So let's pretend that one process is requesting Google's latest data and everything works as predicted. The JSON data is extracted from the reply, sent to the batcher, and the process terminates normally. The batcher receives the data along with well-formatted data from other processes. The batcher spawns a process for each message received, and depending upon which server sent it, it sends the data to its respective database. For example, NASDAQ server will flag their messages with NASDAQ, and that data will only be sent to the NASDAQ database. When an entry is inserted, a log message will be sent to the logger. The logger server works in a similar manner by queuing up messages to write in the log file. The purpose of the logger and batcher is to avoid clogging the system. CouchDB could easily reject some entries if all processes were to create one HTTP request each. Likewise, the system would crash if one process were to print to the log file while another process had already opened the log file for printing. This sums up the basic understanding of our backend software. We have illustrated what happens when the application is run, as well as how each data fetcher functions. Adapa's ETL offers stability, reliability, performance, and is available for download at bitbucket.org.